Good morning, everyone. As discussed, I'm going to start discussing on a topic Spark from the scratch, starting from the architecture of Spark, implementation of Spark, and development of Spark. So in this topic, we'll be covering to understand how Spark behaves, what is a Spark API, what is an RDD, what is a data set, what is a key value pair, what is a tuple, and what are the basic transformations like map, flatMap, and what is cojoins, what is combined by key, group by key, aggregate by key, and all these things. So before jumping into the functional programming of Scala or Spark using Python, you need to understand how exactly Spark looks, how it works, and what is the architecture in the background of a Spark implementation. That is what our agenda today is. Let me move forward. I have updated the slides also, so I think I can cover till that point today. Lambda functions okay, map function okay, flat map okay. Yeah, we'll cover till flat map today. Okay. Okay. What is Spark? Spark is nothing but a platform, or it's an API that allows a large scale cluster based in-memory data processing. When you say in-memory data processing, there are various areas or from various angles you need to understand it. In-memory data processing means, is it doing the whole processing in memory, or is it doing only transformation in memory and the actions will be written to disk? That kind of statistical logical understanding must be very well known before you jump into Spark programming. I'll explain that in a little later. Next slide. Okay. This Spark enables a fast, large-scale data engineering and analytics for iterative and performance-sensitive applications. Iterative means it is a huge, it can be a huge transformation, doing so much of computation, so much of continuous data coming in. You keep on adding data, your transformations keep on working on the data that is coming in every hour, every minute, like that. Okay, that is how it enables the fast processing and data engineering. The Spark offers development APIs for Scala, Java, Python, and R. Scala, I will show you how Scala looks like. Java, I may not be covering here. Python, I'll show the Python modules, and R also I'll touch the nuts and pieces of R. In addition, Spark has been extended to support SQL-like operations, streaming, and machine learning as well. Streaming and machine learning are just the extended capability of Spark, but this is not the flavor of Spark. Flavor of Sparks mean it is with MapR, it's with Java, it's with Python, it's with Scala. Okay, that is all about the Spark is. In a nutshell, Spark is a process that does your computation in memory. Spark does fast and reliable analytics, which can be iterative and which can be highly performance sensitive applications. Spark can be implemented in different flavors, that is MapR, Java, Scala, Python. Apart from this, Spark is also extended towards streaming and machine learning, machine library, and graphics, which we'll discuss in the next slide. Now, before jumping further, you need to understand why Spark is so much tightly coupled with a concept called RDD, which is Resilient Distribution Dataset. Resilient Distribution Dataset is nothing but, your Spark is implemented on a Hadoop cluster. It can be 10 node, it can be 15 node, 20 node, 30 node, it doesn't matter. Okay. In considering to leverage the advantage of Hadoop scalability, Spark processes data in resilient distribution dataset, which is called an RDD. Okay. Now, this RDD is a fault-tolerant collection of data elements. Data elements nothing but you have a file. Your file will be broken into blocks. Your blocks will be split across multiple data nodes. And now you need to understand each file. When Spark is started processing that file, how many blocks is it considering, and for those blocks, how many partitions is it considering? This is a question mark now. This question will be answered in next few slides. I repeat that. When Spark is doing in-memory processing, your Spark has a file eventually which breaks into blocks. When your Spark is reading this file to make it an RDD, the first thing it considers is how many blocks that this file broken into, a question mark. How many partitions does a driver take into consideration before doing in-memory processing? These two questions I'll answer next slide. If you don't answer to these questions, your whole Spark journey will be a confusion. So please be clear on that part. Okay. Now that is the reason why I specifically rubbed very hard on the collection of data elements. If somebody asks you what is an RDD, it's fairly simple. It is a collection of data elements. But the way data is collected is what the beauty of it. RDD is created by starting with a file on disk. Yes, it is started from a file written on a disk. Your file will be broken into blocks, and your blocks will be taken as a partitions. And the way we'll discuss in the next slide. The collection of data in memory in driver program. Each RDD is distributed across multiple nodes in the cluster. This enables the parallel processing across the nodes, which we already know. This is all about resilient distributed data processing along with the leveraging Hadoop scalability with parallel processing across the nodes. Allowing your RDDs to reside and be processed in memory dramatically increases performance, especially when a data sets need to be manipulated through multiple stages of processing. Don't just think I'm going through the slides, but I'm also trying to explain you the logical work behind the theory. So please be focused. It's not practical work. It is understanding the architecture, how Spark implements the whole funda. So you need to be very clear on every important point I discuss here. If you don't understand, you can ask me a question. I repeat this point. Allowing the resilient distribution datasets to reside and be processed in memory dramatically increases the performance, okay, which I agree, especially when a datasets need to be manipulated through multiple stages of processing. That's what I told you. You have a staging layer, you have a data mart layer, you have a data warehouse layer, or you have a pre-transformation layer, transformation layer, and post-transformation layer. At three different levels, an RDD doing multiple transformations, this in-memory processing will give you an adverse advantage of it. That is what we are trying to go deeper. The data in RDD can be transformed and analyzed very rapidly, very easy, and also fast. Now, Spark real time. The Spark project are implemented in real time in various ways for each company. Somebody may use only Spark SQL streaming. Somebody may use only Spark SQL. Somebody may be using Spark Scala, Spark Python, and somebody may be using some different ways of using it. Now, one thing you need to understand is, excuse me, I'm sorry for that. Spark Core is a set of 4 high-level tools that support SQL-like queries, streaming data applications, machine learning library, and graph algorithms. I repeat that: SQL-like queries, streaming data applications, machine learning library, and graph algorithms. If you see my diagram underneath, you have a storage and compute, which is HDFS. You have resource management top of it, which is YARN. On top of it, left side green color, you have Scala, Java, Python, R APIs, flavors of Spark. And it can also be used in machine learning with machine learning library. It can also be used in Spark SQL, having your Hive configurations copied to Spark configurations, Spark streaming, and graphics. Spark streaming, I've already told you how Kafka works, how Kafka drops your data with each and every topic, puts in HDFS, and once it reaches HDFS, how your Spark streaming works and how your Storm topology also comes into picture. This is how it works. Now, Spark REPL shells. For any service, for any software, for any API, there should be way you communicate and the way you get answers, your work done. For that one, we have a project called REPL shells, which is nothing but read, evaluate, print, and loop. REPL takes a single user input, evaluates it, and returns the results. There are two REPLs available in Spark. One is for Python and one is for Scala. These are sometimes referred as partial applications. Yes, that's true. I'm going to show you that as well. Give me a second. Try to understand something. I'll show you three cases. Spark shell, I have just used Spark shell master local. When I used Spark shell master local, it does not communicate with respect to yarn. It just opens as a local Spark process. Okay, now this one, there are multiple versions of Spark are installed, but major version is not set, because based on the project requirement or business functional requirement, you install Spark in different flavors, but one in different versions. One thing you must be very well aware is the two different versions of Spark home directories, two different versions of Spark configurations are not conflicted. That's all you need to do. Okay, now if you see here, my Spark context is available as SC. Okay, you can also see here, one second, I'm just trying to find something. It is also connected to Hive user, Hive warehouse. Okay, it is also trying to your Hive metastore. Okay, so your Hive is also working, which means your Spark SQL, sorry, your Spark is now communicating with your Scala as an API. That's how the REPL works for Scala. REPL is nothing but read, evaluate, print, and loop. Now let me show you something else. Now I have used Spark shell master local, right? I'll just use Spark shell now. See what happens. It will give you a big story, big story. Now here you also have Spark SQL available as SQL context. We have created SQL context with Hive support. We have been discussed it carefully. Once again, I would like to repeat it. Your Spark SQL only works if your Hive site.xml or your Hive configurations are carefully copied or symlinked into Spark configurations. For example, when you go to cd etc Spark default or cd etc Spark, the Spark version which you installed, in both these Spark configurations, you must be able to copy your Hive configurations and hiveset.xml, so that once you copy it, you have to make necessary changes in your Spark home directory, your Spark environmental variables, your Spark class path, and then restart Spark. That's how it will work. So Spark shell master local will start invoking Spark in the local mode. Spark shell will start integrating with yarn mode. That's all the difference is. Okay, now we have seen with Scala. Now let's see with Python. For Python, all you need to do is PySpark. In this one also you can do PySpark master local, but I'm just showing you how PySpark works. This is about your Python, and this is how your Python modules look as PySpark flavors. Okay, to exit from Python, you just need to do this one. That's it. You're exited. Okay. Now, in order to start Python shell, user need to enter PySpark on command line, or in order to start the Scala shell, user need to enter Spark shell on the command line. Perfect. That's what I have shown you now. Now, enterprise level Spark applications. Guys, very important. Focus. There are 5 core components of an enterprise Spark application HDP. One is driver, next is Spark context, third one is yarn resource manager, fourth one is HDFS storage and executors. Now, what is driver? What is Spark context? What is yarn resource manager? What is HDFS storage and executors? How each and everything is interlinked and how they would behave from start of an application submission to end of an application execution. Let's talk about it now. When using an REPL, which is read, evaluate, print and loop, the driver and Spark context will be running on a client machine. For example, when I launch this one, this is my client machine, and my cluster is somewhere else. REPL is now taking me from here to the cluster. So immediately when I open an REPL, a driver is initiated. Along with driver, the Spark context is also initiated. This is where it is. Okay. The Spark context and your drivers are now open with a connection. Okay. Now, when deploying an application as a cluster application, the driver and Spark context can also run in a yarn container. Okay. I'll repeat that. When you deploy an application as a cluster application, so what you need to do is you have done your testing, you are ready with your code, and now you're deploying it on your cluster and you want it to run on the cluster. When you are running it on the cluster, your driver and Spark context will be running in the yarn containers. Okay, in both cases, Spark executors run in yarn containers on the cluster. Fairly simple. So this slide's important motto is to help you give an idea what is executor, what is driver, what is Spark context, what is yarn resource manager, what is HDFS storage. Okay. Now, Spark driver. The Spark driver contains the main Spark program that manages the overall execution of a Spark application. It is nothing but a JVM that creates a Spark context which then communicates directly with Spark. It is also responsible for writing, displaying and storing the logs that Spark context gathers from the executors. It is not just logs, it is also about your intermediate outputs, about your logging mechanism, about your resources, containers, schedulers and everything. The Spark driver in context with your Spark driver in association with Spark context can do the work, but for them to do the work they need resources which is managed by yarn resource manager. I repeat this point. Spark driver is the main thing that contains a main Spark program that manages the overall execution of the Spark application. This is nothing but just creating a JVM. Okay, within the JVM there's a Spark context. This Spark context communicates from driver to the cluster, and it is responsible for execution and also writing the logs during the execution process. Now, Spark shell REPLs are example for Spark drivers. Yes, your PySpark is an example for your driver, your Scala is an example for your driver, and the way your Spark context is invoked through RPL, we have already seen it. Now, the important point you need to understand here is the Spark driver is a single point of failure for yarn client applications. If driver fails, the application also fail. This is mitigated when deploying applications using on yarn cluster. If you don't, always your testing will be done with REPL shells. But once you are finally testing, the deployment or the job is allowed to run on your cluster using yarn only. Because if for any reasons one of the driver fails, at least other drivers will take the responsibility of it. That's how it works. Now, why is Spark context very important? We were talking about drivers. We are also talking about Spark context. Now let's deep dive into Spark context. For any application to become a Spark application, an instance of Spark context must be initiated. The way it works is, when you, let me show it here. When you launch Spark, you clearly seen Spark context is available as SC, Hive context available as SQL context. Okay. The important point you need to understand here is why this Spark context is invoking immediately when I start Spark. That is where the magic is. The Spark context, which is SC, contains all the code and objects required to process the data in the cluster. This also works with Yarn Resource Manager to get the requested resources for the application to work. It is responsible for scheduling the task and executors for Spark. The Spark context checks in the executors to report work being done and provided log updates. We know that very well. A Spark context is automatically named as an SC, which I have just shown. When REP is launched, the following code is executed to start up for PySpark in the background. As you have already integrated your Spark with Yarn, you won't see this in the front end. This runs in the back end. If you install Spark on your local Windows laptop or on your Mac machine, if you wanted your Spark to work, first thing you have to do is you have to import the Spark context. When you import the Spark context, you are initiating the Spark configurations to a variable called SparkConf. Once the variable initialization is done, then you are giving the configurations of Spark as SC, and that's how it starts picking up and will work. Okay, hope I'm clear on this one. Anyone, any questions, let me know. Now, Spark executors. The Spark executors are very important. The way you have your driver, the way you have Spark context, and your driver is the one that does exactly the work it has to do. The Spark executor is the component that does perform map and reduce task of Spark application. Okay, and once again I repeat, Spark is a non-map reduce application, but still the framework looks like MapReduce only. Okay, that's the reason it says like performs. The Spark executor is the component that does perform the map and reduce task for Spark application, and it is sometimes referred as Spark worker. Once created, executors exist for the lifetime in an application. Okay, executors are nothing but the one which executes your task. Now, Spark executors function as interchangeable workspaces for Spark application processing. Okay, I repeat this very sensitive and important point. Spark executors functions as interchangeable workspaces for Spark application processing. For example, if one of your executor has finished the work, the resources of that executor can be shared by some other resources. For example, if one of the executor while working is dead, the work that is done by that executor till that point can be taken by some other executors. The interchangeable means if an executor is lost while an application is running, all tasks assigned to it will be reassigned to another executor. Point number one. Point number two, in addition, any data lost will be recomputed on the other executor. Two things. If it has lost only processing work, it will be reassigned to another executor. If it also has lost the data, okay, it will be recomputed again from the scratch by another executor. Executor behavior can be controlled programmatically. Configuring the number of executors and the resources available can be greatly increase the performance of applications when done correctly. Your capacity planning for your Spark cluster must be done very carefully. When you know the amount of resources that's utilized by your Spark application, that way the number of executors and the resources must be in line. Okay, now RDDs. The resilient distribution dataset is an immutable, distributed, and resilient collection of elements that can be operated in parallel. I know I have been telling you it is a distributed parallel processing. When you say distributed parallel processing, how is that RDD supporting distributed parallel processing, which is immutable, distributed, and resilient collection of elements? RDD is composed of one or more partitions that can be distributed across the nodes in cluster. Now don't confuse yourself why this guy is again telling partitions. I'm going to show you very clearly with one of the example what exactly a partition means to a Hadoop cluster or to a Spark cluster. These partitions are immutable, meaning when a change occurs in one of the RDD, the new RDDs are created rather than having those changes written to the existing RDD. Okay, I'll show you very clearly in the next slide. They are also resilient, meaning if RDD partition fails, it can be recreated on an other node. So all the RDDs are resilient, all the executors are resilient. Two things. Now, for HDFS files, the RDD partitions will be aligned with the file blocks to maximize the parallelism and other Hadoop infrastructure benefits. RDD partitions will be aligned with the file blocks mean, for example, if you have one file divided into 3 blocks, okay, based on the locality of your blocks, you have mappers. Based on the availability of the blocks within the nodes, you have partitions, which we will discuss in the next slide. Okay, that's what about RDDs. Once again, resilient distribution data sets, which is nothing but collection of elements doing the work parallel. Point number one. Point number two, RDD is composed of one or more partitions, which we'll be discussing in next slide very clearly. Okay, and this is resilient, meaning if one RDD fails, it will be carried forward by another RDD. Okay, and in with the context to HDFS, the RDD partitions will be aligned with the file block size to maximize the performance aspect of it. Now, creating RDD programmatically. Okay, this I have discussed, and I would like to very clearly make things, because if you understand this one only, you'll understand a map function. If you understand map function only, you'll understand a flatMap function. If you understand map and flatMap, only then you'll understand a combined by key. If you understand map, flatMap, and combined by key, only then you'll understand aggregate by key. If you understand map, flatMap, and aggregate by key combined by correctly, only then you can do a dense ranking functions. Every single thing is interlinked here. If you have a gap in one of the way of doing applying a transformation, then you'll have to start coming from the scratch. That is the reason why I have taken the leverage to rewind, repeat, make things clearly documented solidly. Okay, so Spark, just love it. Spark, just understand it. Spark, just don't miss anything. Okay, now creating RDD programmatically means, for example, you have an RDD, which is nothing but resilient distribution data set. This resilient distribution data set is collecting elements. The elements it has collected, how are you converting that into RDD is the point here. For that point, the answer is users can programmatically create RDD list of numbers or text values using sc.parallelize, which is an API once again. This is useful for learning Spark and distributing local connections of data to the cluster. Okay, for example, if I do it here, is given RDD or read RDD numbers list equal to sc dot parallelize. In that we have two things here. I have 1 3 5 7 9. Okay, perfect. Now RDD num list dot collect. It is collected. If you see here, now it has taken like this. I'll give you another example. I'm taking out these brackets. See what happens. See, it has taken, sorry boss, parallelize at most needs 3 arguments. For that case, let me try this way and let me show you what it does. It does the same thing because it always needs a proper formatting. This is called syntax level interpretation of data. Okay, now we understood how you can read the RDD. Now this sc.parallelize is creating an RDD for 4 numeric values. To confirm RDD is created and contains the correct, we just have to use collect statement. I have already showed you that. Let me do once again. Okay, now it has taken 13579. Now let me do RDD text list. Okay, RDD text list. This is equal to sc dot parallelize. Okay, case sensitive, be careful. You got it right. That's how you can read numbers, integers and text. You can also make combination of both. Let me show you something more actually. Now if you see here, this is the corrected slide. Okay, I'll show you something. RDDs can also take variable values as input. Variable values of input means you have given a text file. Okay, let me show you this. You have given a numbers, you have given a text file. Apart from numbers, apart from text file, you can also give variables as an input file. Now once you give variable as an input, you need to create a variable name and then assign it to a string value. Okay, now I'll give a name as, which one is like this. This is something I give as a statement. Okay, now what happens is you have created a variables as input. How are you going to define these variables as a data set is the point that comes up. Okay, now this is just a variable and you have a string. Now to create an RDD, you have to assign it to your RDD using sc.parallelize. For that one, what I'm going to do is RDD Amarnath equal to sc.parallelize statement, which is an API. Okay, in that I use this file. The file name is Amarnath file. Okay, now if you see here, if you see RDD Amarnath dot collect, do you see that it has taken the statement correctly? It has now given the distributed data set, resilient distribution data set. Now you need to understand something here. The square bracket around the variable name prevents the variable input from being read one character at a time. If we have used a curly, if you have used a circle brackets instead, the collection would have written individual names. Let us try that one. Let us try doing that one. Do you see that, guys? Did you see the magic? Everyone, did you see the magic? Once again, I do that for you. Focus if you haven't. Here I am doing this one. I'm applying I'm applying a square brackets inside. Okay, and now this is a different way of giving inputs. I've given different way. Now RDD Amarnath dot collect. Now the whole string is taken as one input set. If I enclose it with square brackets, on top of it circle brackets, I'm going to change the way I give input. Now observe. Now observe everyone. This kind of understanding is very important, because you think you are given correct input, but you might have given square bracket and circle bracket. Now see the magic. See, A is one input, M is one input, A is other input, R is other input, and space is also one of the input. I is one input, S is one input, space is also one input, A is one input, space is also one input, S is a input, T is an input, strong is one input, space is one input. This way each and every letter, okay, is taken as, okay, is now an input for your RDD. That is the difference. Yesterday earlier this slide was not highlighted with this thing. I made the corrections because I had a very limited time to prepare the slides. Okay, that is where we are coming from. Once again I repeat, be very careful while you give syntax in Spark. It can be Scala, it can be Python. You must be very careful when applying map function, when applying Lambda function, when you know your output must be a key value, your approach will be different. When you know your output will be key and combination of values, your approach will be different. When you are applying your transformation of a tuple, your value is different. If you are applying a transformation of string of variables, your approach will be different. That kind of logical basic thinking is must and should. Okay, try to tune your thought process approach like that. Hope you understood the difference, what really it makes if the variable input is with the closing brackets or with the circle brackets. Okay, so with this one I have finished the slide. We have understood how an RDD works. Okay, now this is where we are talking about other way of inputting the RDDs. Inputting the RDDs is like you have a concept called, another way to create an RDD to load it from one or more text files is sc.text file. These files can be located on local storage or cloud or network. For example, if you want to create an RDD from text file on your local drive, you just give RDD local sc.text file. If it is an HDFS, you give the full location of HDFS. Okay, multiple files can be read using comma, which is this one, and wildcards can be implemented with this one, which is this one. Now let me show you something. Crazy. Okay, I'm exited. Now let me go to Hadoop fs minus ls. User Hadoop dot works. I'm sorry, it's a spelling mistake because it shouldn't be dot here. Okay, Hadoop fs minus cat user Hadoop dot works. It's a directory, spark test .txt. Okay, now this is what it is. It has read the file. Now if I go to local, I have one thing here. I'll do other test, create spark demo.txt. Append. Okay, now I'll put it Hadoop. I have two files here, ls-l, Hadoop fs minus put spark demo.txt to user Hadoop ThoughtWorks. Yes, I mean put, I'm sorry, I have to give it like this. So from my local directory, it is going to Hadoop ThoughtWorks. Okay, now I have two files. I'll open PySpark now. Spelling mistake. Guys, give me a second. I'll be back. Just a second. I'm back, guys. Sorry for that. Okay, now let me do that sample test. RDD HDFS equal to se dot text file. In that I have user Hadoop .works. I have Spark demo.txt. Okay, done deal. Okay, now if you see RDD HDFS dot collect, it has taken Amarnath and team is on Spark and going well. Okay, now let me go and show you something else. Comma user Hadoop .works and then paste it here, which is sparktest.txt. Take input. The reason why it failed is if it says an error occurred while calling textfile.trace. Let's go back to the slide and see the syntax correctly. It is telling your file location 1 and file location 2. So let's take that additional columns here. Okay, you just have to put the quotes starting and ending. Okay, now RDD HDFS dot collect. RDD HDFS, not DFS. Sorry for that. Now if you see here, this is key and the whole set is a value. Till here, this is key list of values. This one is one value, this one is other value, or this is key, this u, under u this is value, and this is other key and this is value. Okay, now let's see how we can do the wildcards. Okay, input you can give like this. While you give input, you have to mention like this and star dot spark, so it will pick only the spark part of it. Okay, RDD HDFS dot collect. It failed because our requirement doesn't match. So what we'll do is we'll take that off. We'll give only for one line. Okay, this is getting confused if you use multiple lines for the wildcards. File location. Okay, now RDD HDFS dot collect. It is again failing, so what I'll do is I'll give the input as this way. Okay, in that directory go and say, yeah, that's what, yeah. Wildcards, why is it not working?
Should we start the text, not Spark?
No, I wanted to search with Spark words. If you see my words, if you see my, wait, hold on, I'll show you something. Not this one, sorry. Okay. If you see here, there's a word Spark, right? I want to collect those things with respect to Spark as my wildcards. That's what I was trying to achieve here. Let me see how it takes as .txt if I give .txt. It has taken the whole set. The requirement is, in this requirement, he is picking up all the text files. But what I wanted to do is, I wanted to pick up, that's what I tried to funny. That's what I tried. If you see here, I'll just take out Spark and give dot Spark, okay? Or just Spark. I'll find it out. I'll find it out. Star dot. Did we give star dot? No, we haven't given star dot. Star dot Spark. Okay. Now RDD HDFS dot collect. It is failing. I'll find it out. I'll find out the reason why it's failing. Might be a syntax error or something. Don't worry about it. But we have read how to read the files from HDFS individually, combination of multiple files, and also if an RDD contains all text files that meet wildcard requirements given location. Here what he's telling is, in your HDFS directory you have text files, you have paraquery files, you have sequence files. If you want to read all the text files, then you have to give .txt. Like that, within the txt file, I wanted to pick a wildcard. I have a word Spark repeated multiple times, so I wanted to get that count, get that words that are with Spark, which might be a different approach. I'll have a word, I'll have a look, but wildcard usage is just giving the wildcard expression at end of your HDFS statement. Okay, hope everybody is happy till this point. Any questions, let me know. Now this is the new way of, this is the new this is the second area where we need to focus and understand, from data files to HDFS, from HDFS to RDD. Guys, look at the diagram, try to understand very carefully. Your HDFS has got three data files, which is data file 1, data file 2, data file 3. In this diagram, your data file 1 is sitting in node 1. Your data file 1 is also sitting in node 2. Your data file 2 is also sitting in node 4. Now let's understand how this data file 1 and 2 will be read as an RDD to the Spark cluster. Let me take a diagram here or a pen. Now carefully observe data file 1, data file 2. This data file 1 is on node 1. That is the reason why I'm saying 1.1. This data file 2, this data file 1 is on node 2. That is the reason why I'm saying data file 2.1. This data file 2 is on node 4. However, I have given 2.2. Clear? Now this is RDD 1.1, 1.2, 1.3. This one, and this one are now processing on three different nodes. Here your RDD1, okay, is nothing but data file 2 plus data file 1. This is your data file 2, okay, this one is your data file 2, okay, and this one is your data file 1, and this one is your data file 2.1. Means data file 2.1 and data file 2.2 are on node 2 and node 4. Okay, these three are now taken as one RDD for the Spark application. I'll clean this off. Okay, I'll explain that once again. These three or you're on HDFS, but you're submitting on this one and this one to your Hadoop cluster. Now your data file 1 is on node 1. That's the reason I called it as 1 and 1. This is your data file 2 sitting on node 2, that is 2.1. You have data file 2.2 means your second file is split into two blocks. Try to understand. The first block is here, second block is here. Okay. Now when your RDD reads it, it takes these two things as one thing and this one as other thing, means combination of elements. This combination of elements is now an RDD. How partitioning is happening in this RDD, we'll discuss now. Okay, let me go to that point now. Spark application that initially defines an RDD that is made up of combination of data in data files 1 and 2. Okay, in HDFS there are two files that are represented by three HDFS blocks, that is 1, 2 and 4. Okay, I repeat that. In HDFS the two files are represented by three HDFS blocks. These two files in three blocks. Please be informed, we are not talking about any replication factor here. We are only talking about the original copies. Okay. Now, when an RDD partitions are created in memory, the nodes, 1 minute, yeah. When RDD partitions created on memory, the nodes will be the nodes that contain the data block in order to improve the performance and reduce the network traffic that would result from pulling the data from one node disk to another node's memory. Once again, focus. As I said, your map reduce always tries to run on the local node, nearest to local node, to reduce the network traffic of transferring the data from one node to other node. Here in Spark, the node that will be used is nothing but the node that contains the data blocks. Here we are improving performance by, if your data node and your Spark in-memory working node is same, you did not have to travel the data from your disk of that node to the memory of this node. Point clear. Now, the three data blocks that represents two files were combined by Spark application and then copied into memory by the respective nodes and becomes the partitions of RDD. I repeat this point, carefully observe. The three data blocks, okay? These three data blocks. What happened? Okay, these three data blocks which I'm talking about is this one, and this one. Okay, how can I? That's okay. We are talking about these three data blocks now. The three data blocks that represent two files were combined by Spark application and then copied into memory by the respective nodes and becomes the partitions of RDD. Partitions of RDD is nothing but the data elements that are combined based on the file splitting to block splitting. Okay, that is one idea you need to understand. Now, data file 2.1 is written to RDD partition you are labeled as 1.1. Means 1 minute. Your data file, once again, your data file 2.1. This 2.1 is written to RDD 1.1. Fair enough. And your 2.2 is written to an RDD partition which is 1.2. Okay, your 2.2 is written to your 2.2 is written to an RDD partition as 1.2. Okay, and your data file 1.1 is written to an RDD partition we have labeled as 1.3. Okay, if you see data file 1.1, it has a partition RDD 1.3. So in here you have three partitions. Okay, in our example, one RDD was created from two files which are split across three HDFS data nodes which exist in memory as three partitions. Why 3 partitions? Because one of your file is split into 2 blocks. For each block you have 1 partition. So totally your 2 files are read from 3 blocks. So you have 3 partitions created for your in-memory processing of your RDD. Now this diagram should give you a clear picture how your driver will communicate your Spark cluster in terms of processing the data. If you don't understand this, stop me here. If you don't understand this concept, there's no point in moving forward. Clear everyone? Can I go ahead? Perfect. Which one you want me to repeat? Which point you want me to repeat? It's fairly simple. There's nothing to confuse. Okay? I'll repeat that once again. Though you have 3 data files, we are only talking about this one and this one. Hope you're clear. Okay? Now one thing you need to understand is your data file 1 is on this node with only 1 block. Okay? But your data file 2 is divided into 2 blocks, which is 2.1, which is also 2.2. This is on node 2, this is on node 4. Now if you see very carefully, the way RDD understands is, for this data file, for this block, it is 1 RDD partition. For this data file's first block and this data file second block, it will be 2 partitions. So in here it has 3 partitions in memory. This 3 partitions are nothing but your data file 1 partition plus your data file 2's 2 partition. These 3 partitions will be submitted to Spark cluster. For example, if you have 3 partitions now, you have 3 threads open. These 3 threads will run parallelly. Okay, for parallel multi-processing computation, whichever process you have 10 threads released for these 3 partitions. In this 10 threads, whichever threads finishes the work first will be taken into action zone and the rest all will be elapsed. Clear now everyone? Clear now everyone? Any questions? Funny? Hope I'm clear. If not, let me know. I'm happy to repeat again. No problem at all. Don't confuse. Please, foundations must be very strong. Foundations must be very strong. Throughout your journey, you work with Spark for 5 to 6 years. This 1 week, this 10 days, how you learn Spark will give 5 years of your journey in terms of development. Don't take things easy. Every minute is important here. Every minute bit is important. Why like this? Why not like that? Think. Bug me with your questions. If you think the class is going beyond, we can talk offline. But think, why is it like this? Why is it like this? Why is it like this? Why is it working only like this? Why not like this? Why? What exactly is it doing like that? Think that way. You will get answers by yourself. Okay? Once again, don't take me wrong. If you understand and work carefully on Spark, you will be treated as a I don't know, I have faced it. That's the reason I'm telling you. If you're a Spark developer, if you're Spark certified, and if you have good hands-on experience on Spark, you are treated uh, as a special guy in your office. That is the importance of Spark has got. Oh, you know Spark. Oh, is Spark certified? Oh, is it? That kind of treatment. Okay, leave about the treatment. It's all about money. It's all about how much you earn on a daily basis or monthly basis. So that is also important. Learn it seriously. Understand the core concepts. Understand the architecture. Understand each and every minute bit. Okay. So hope we are clear till this point. I'm moving forward now. Where is Gopi? Did Gopi come to class today? Okay. This is done. Now guys, there is other way of explaining the concept which I'm trying to come up here. And a hypothetical cluster, if you see here, an hypothetical cluster has two RDDs. Each RDD is composed of multiple partitions. Here, in here, you have three partitions for two data files, where data files have blocks spread across. But here, what I'm trying to understand is, I have two RDDs. Each RDD is composed of multiple partitions. Right now, RDDs can contain at any type of serializable element, meaning those can be converted to and from byte stream. Example, int, float, bool, sequence, iterative like arrays, lists, tuples, and strings. Each element types in RDD can be mixed as well. For example, an array or list can contain both string and int values. Furthermore, RDD types are converted implicitly whenever possible, meaning there is no need to explicitly specify the type during RDD creation. Very, very, very important. In schema creation, anywhere in the world, you have to tell, is it int, is it text, is it big int, is it boolean, is it what, for your process to understand what kind of data you are giving as input to read or write, you have to define the data type. In RDD, there is no such things, because RDD has the capability to convert the data types implicitly, and there is no need to explicitly call out what kind of RDD and what kind of data types you have in RDD. The reason is, if example you take your int, float, boolean, sequence iteratives like arrays, tuples, strings, each element can be mixed as well, but anything you give, I'll convert it. I know how to convert it. I know how all the artifacts of each and every data type, and I can read it. That is what the magic of RDD is. Okay. Now, RDD operations. There are two kind of things you must be aware. One is actions, one is transformation. Your map, your flat map, your group by key, combine by key, reduce by key, aggregate by key, co-group, blah, 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 all are transformations. They are transforming. But action is the point where the transformations is giving the results. Okay. Now let me give you a theoretical understanding. Transformations take an existing RDD, applies a function to element of the RDD. Focus. The reason why I underlined the function to element of RDD is, when an RDD is read, each line is one element. Each input string is one element. Now, your transformation will be individually applied on each element in the RDD. I want you to understand that very carefully, logically, and clearly. Now, once the transformation is applied, a new RDD is comprised of the transformed elements, but not the results. You have 3, you applied the transformation, 3 became 2, but the 2 is not a result yet. 3 is just a transformation. Until and unless you give an action, that will still be an in-memory transformed data. Okay. Now, transformation is applied as a function to an element of the RDD. To element of RDD is, in an RDD, if you have 5 elements, the transformation has to be applied on each and every element in an RDD. Try to understand. Try to focus from that point. Your transformations will be easy while you write them. And action returns a result of a function applied to element of RDD in the form of screen output, file write, etc. Action is nothing but, now you did something, show me the result of that something. That is nothing but action. That is where the RDD operation comes into picture. Okay. Now RDD has two things. You have operations, you have actions, transformations. Transformation is the work you are doing. Action is the result of your transformation. Hope everybody is clear with that one. Now, Spark programming basics. Guys, here we are starting writing a Spark programs, understanding what is that you need to write a program and all these things. Okay. First thing I have to make you a difference is difference between functional programming and non-functional programming. The functional programming is very simple. In functional programming, you are not relying on data outside of the function. You know what your work is doing. You define a function, and whatever you do, that will be within that function. Your data will not be read will not be modified outside that function. Okay, take an example here. Let me diagrammatically or show you this. Okay, here one thing you need to understand is this is your function. Okay, you have defined a variable outside of your function. Okay, and what happens is your variable outside your function, you're calling it out and you're making some changes. I repeat that. You have defined a variable outside of your function, which is fine, and then you're pulling that value into your function. I have given var value equal to 0, and this is my function. And again, the function, the value what I have defined here, I'm using exclusively out of my global function. Okay, now if you think about functional programming, the same work can be done within the function. This is the function. Within the function you have defined a variable, and immediately you are applying changes to that variable within the function. You are not coming out of it. But here value is defined separate, function is separate, and you are calling your variable again, and you are applying transform change to your variable again, which are 4 different steps, making a difference in the way how your external outside of the function data can be read and modified. Here this time the variable value is instantiated as a part of calling the function itself. Within the function itself you have this variable, and you are making changes, or you are modifying the function and the value within that instantiation, not external. That is the difference. The reason why I told this one is this is where the RDD comes. Your RDD comes into picture, where you have an immutable, or you have a transformed set of elements which will be given to a new RDD. At the next level of transformation will be done on that RDD, and will give the third RDD. So this way your functional programming will be implemented when data is collected as elements, that elements converted as RDDs, RDDs started transforming, transformations run into actions and results. Okay, next thing, this is over, and next one. The need to operate on different partitions of same RDD in parallel makes the functional programming a requirement for Spark. I repeat the statement. The need to operate in different partitions of same RDD. I have told you an example here. This example, if you see, you have an RDD wherein one RDD came from different partitions, 3 different partitions, wherein 2 partitions of one data file and 1 partition of one data file. Picking the data from 3 different ways, and that is how the need to operate different partitions of Spark in parallel makes a functional programming a requirement for Spark. That's a basic thing. If you don't understand this, and if you start working on Spark, that doesn't make any value to your learning. So functional programming is very important. Now the Spark programming has following characteristic features. You need to understand them very carefully. Immutable data. Immutable data means, I told you very clearly what immutable means. Let me reiterate that. Resilient distribution data set 1A can be transformed into resilient data set 1B, but an individual element within the RDA cannot be independently modified. Hope you got that clear. The transformed data, the transformed elements of your RDD can be transformed to RDD 1B, but individual elements before transformation, before manipulation, cannot be moved into a different RDD. No state or side effects, which means no interaction with or modification of any values or properties outside the function. I have shown you that is the difference between functional programming and non-functional programming. Okay. Behavioral consistency. If you pass same value into the function multiple times, you'll always get the same result. Changing the order of evaluation does not change the result. Until and unless your value is changed, your results will change. If the value is same, you do whatever the value will be, the result will always be the same. Functions as an arguments. Very important, very sensitive, very logical. Focus. Function results, including anonymous functions, can be passed as an input argument. I'm going to extend the class. Seriously, I'm going to extend the class. No compromises. People who for whom it's getting late, you can leave. Okay. I'm going to extend the class till 7. You have to bear with me today. Okay. Functions as arguments. Function results, including anonymous functions, can be passed as input arguments to other functions. I'm going to explain practically this one in next slide. Bear with me. So here you need to understand RDD means immutable data. RDD means a no state or side effect. RDD means behavioral consistency. If you pass the same value, hell or heaven, your results will always be same. The order of the execution will not make any difference. Functions as arguments means a function can be passed, one function result can be passed as input to other functions, or function itself can be passed as an input. Lazy evaluations. Function arguments are not evaluated and executed until required. Means all your transformations are lazy. Until your transformations are turned into an action, they are all in memory. Okay. Hope everybody is happy with this slide. Let me move on to the next thing. Okay. Anonymous functions or Lambda functions. Guys, very important. Put aside your Java Lambda function feature and understanding. Park that aside, and now coming to your Spark and Scala and Python Lambda functions. Lambda function is a kind of anonymous function. This Lambda function is used heavily in Spark programming, very heavily. They start with the declaration of the anonymous function by using a keyword Lambda. Okay, let me show you that. This is the keyword Lambda. Hope you understood very clearly. The Lambda functions, they start with the declaration of the anonymous function by using a keyword Lambda. Very good. Then a programmer provides a variable name that will be used in the function body. This is the variable name. Okay. Anything after that variable is the work of the function. Now let me reiterate. A Lambda functions in Spark will be starting with declaration of an anonymous function by using the keyword Lambda. So this anonymous function, Lambda is my name of the function. Okay. You are just defining, you are going to use Lambda function. After that, you provide a variable name which is Z. This can be Z, this can be A, this can be B, this can be Amanna, it can be anything. Okay. Now, after that, what happens is, after giving a variable to your anonymous function, you will be followed by a colon. That is this colon. Okay. Now, to write off colon, you'll have the function body, which is this one, which is nothing but a function or a call to other function or a function to result the work. Now, here is the example. This example, what he is telling us is, he is telling very clearly, boss, for me, Z is anonymous function. My anonymous Lambda function is just named as Lambda function, and I have defined a variable for my Lambda function. And then I'm asking my function to apply +1 to my variable. Now, as I said earlier, in Spark, a function will be applied on each individual element. So when you set Z +1 means 6, 8, 12, 15. So this Lambda Z means I'll delete it and I'll start again. Okay, your transformation must be applied on each element of the data set. So everything is Z. Z plus 1 means 5 plus 1, 7 plus 1, 11 plus 1, 14 plus 1. That's how you get results 6, 8, 12, 15. Okay, let's go and try working that out. Okay, there's no space, sorry for that, there shouldn't be space. Okay, now we have defined it correctly. Now let's see how we apply the map function. RDD mapped is equal to on num list. I am applying a map function. On top of map function, I use Lambda as my anonymous function, and for that one I give Amarnath, and then I'll give Amarnath plus 1. Okay, this one can have place or cannot have space, which is fine, but make sure where your bracket start and where your bracket ends. Okay, the syntax error because lambda z, did I give overspace? No, it is perfect.
Lambda spelling.
Spelling mistake, sorry guys, I'm sorry for that. I always do this mistake. Okay, now if you see RDD mapped dot collect. Okay, you got 2, 4, 6, 8, 10. I have given odd numbers here, which is 1, 3, 5, 7, 9, and I got output as 2, 4, 6, 8, 10. Forget all the shit. Only thing you have to understand is, my dear guys, lambda is one of the anonymous function. I have defined a variable called z, and from that z will be applied to each individual element in the data set. And this colon says lambda anonymous function invocation is done, variable defining is done, any shit after this colon will be the function. That's how you invoke it. It will start working. Now let me do same thing here. You can give any shit, it doesn't matter. Hold on, all the questions I'll answer next minute. Give me a minute. Do you see that? You can define anything, it doesn't matter, but the syntax should be correct. Anonymous function followed by defining a variable, followed by a colon, followed by a function. That's it. That's the wonder. Now let me answer the questions carefully. Is only addition or you can do any operation. You can edit, you can add, you can sum, you can average, you can aggregate, you can completely change the data format, you can change anything. We'll discuss it later. Any transformation applies, sir. You can be iterative, you can be commutative, it can be average, it can be aggregate, it can be a complex transformation of doing dense ranking. You can rank who got the first in your batch, all these things. I'll show that later, don't worry. We need to finish the topic first. Hope I answered your question, Ram. Okay, cool. Now let's come back. Anybody any questions on this one? On this slide? Everybody happy? That's how you implement lambda functions. Now the basic transformation is map function. You need to understand now, guys. Now let me tell you something. I don't know why you didn't get the question. Amar, you said lambda. I'm happy. Why the hell, where the hell this map function came from? You should have asked me. I told you, start focusing on each and every nook. Why? Now, when I used lambda function, I told lambda and used it. Fair enough. Why didn't you get a question? What is map? You should have asked me. Amar, what is that map? You said me Lambda. I got it. But why is map used here? You should start. No, I'm just telling you. You should start thinking that way. Now I'm going to explain you what is a map function is. What is a map transformation is. Okay, let me go back to my slide. Guys, map is very simple. When you use Google Maps, you go from one place to other place. Like that. In Spark, map transformation just applies a function supplied as its argument to each element in RDD. Okay. Once again, your map is a transformation that is applying a function, and this function is supplied as an argument to each element. Once again, focus, understand, understand, understand. It is nothing but a transformation. A transformation is applied as a function, and this function is supplied as an argument to each element. That is the reason why I have stressed very hard that your argument must be supplied to each element in dataset. Your function as argument to each individual data set or each individual element, this complete bit of work is done by map. Okay, when you apply map, if you don't apply map and do anything, you will not go anywhere, because your RDD transformation on any RDD to be applied on each individual element, you have to specify map. First map, only then anything. If you don't do map, on where should I do? What should I do? Where should I apply the transformation? That is where the point is. Now, let's see. We have a list of numbers that make up our RDD. Yes, we know that. We have read that very clearly. A block, a partition, and an RDD. List of elements in RDD. Now, we then apply a map function and instruct Spark to run anonymous function. I told you very clearly, using Z as a variable name for each element, Z plus 1, and immediate print out the results. Okay, I have shown you this one, so I'm not going to repeat this again. But one thing you understand, map. Map is nothing but your function is applied or supplied as a argument to each individual element. Okay, now map can apply to strings. Okay, here are the example that starts by reading the file. Okay, now let me show you. I'll do this practically. I'll just take another half an hour. We just have 2 slides, but I have to show you practically. Okay, what is my file name? amanora.txt. Okay, I have 4 lines. Amarnath was training Hadoop. First line, Amarnath was and is training Hadoop. Now he wanted to make Spark easy to his trainers. He wanted to make Spark easy to his trainees. And the third one is everything is going well as per the plan. Everything is going as per the plan. Now they are all desperate and committed. Okay, these are the 4 lines. Now try to understand something what I'm going to do. Okay, escape colon WQ. Now Hadoop fs minus put amarnath.txt into user Hadoop thoughtworks. Done deal. Okay, sorry, you always do this mistake. Hadoop fs minus put. Now let me see Hadoop fs minus cat user Hadoop thoughtworks Amarnath dot txt. Okay, yeah, 4 lines. Amarnath was and he's training Hadoop. Everything he wanted to make Spark easy to his trainees. Everything is going as per the plan. They are all desperate and committed. So I have 4 lines here. Now, with these lines, what you need to understand is we'll read this file as text file. We use a API called sc.textfile. I have shown you that very clearly. Now, what you need to understand is RDDs created using text file method treat new line characters as a characters that separate the elements. In this case, as you have 4 lines, your 4 lines will be used as 4 characters. I repeat that, everyone please focus. Text file method will treat new line characters as characters that separate the elements. So here you have 4 new lines. These 4 new lines acts as elements separating each and every line. So one line is one input. So you have 4 inputs now. Okay, park your understanding there. Now since the file had 4 lines, the file has shown the image would have 4 elements in RDD. Now let's do that. Okay, I'll open PySpark. If you see this PySpark, let's the RDD line split equal to sc dot text, sorry, t should be small first, sc dot text file. You have user, you have Hadoop ThoughtWorks, and then you have, what is that, amarnath.txt. Always make sure you check before you go ahead. So RDD line split dot collect. So we have everything now. Okay, if you see here, this is one key. Just understand like that. One value, one key, one value, one key, one value, one key, one value. Okay, it is just list of values or list of strings, I can say. Okay, now guys, carefully understand. I am going to apply a map function on top of it. This map transformation is then called. The goal of map transformation in this scenario is to take each element, which is string containing multiple words, and break it up into an array that is stored in a new RDD for further processing. I repeat that. I want everyone to make a note of it. The goal of map transformation in this scenario is to take each element. Okay, each element is each line, and each line is a string containing multiple words. You know, I know, very good. And break up an array that is stored into a new RDD for further processing. Let me do that. Okay, now what is my old statement? RDD line split, right? Now what I'll do is RDD line split dot map function. On top of map function, I do line split. Okay, I'm not applying any lambda. I'm applying a lambda function here, which is lambda line split colon line split. Okay, your line split must happen with space. Okay, now let's see what it does. Guys, once again, I'm using a map function and then lambda as anonymous function. I'm defining a variable called line split and I'm using a colon. Anything of the colon will be this one. Now understand that one. Now it has created. Now let's see RDD line split dot collect. Do you see that? It has done no big difference, but it separated each line as one element. Okay, each line is separated and each line is taken as one element. Now let me go to next slide. Okay, wherein I apply a flat map. Okay, anybody, any questions on this one? Guys, anybody, any questions on this one? Any questions, let me know. There's no point in going forward if you don't understand this one. I repeat once again, your map function is nothing but it is a transformation which takes your individual elements as inputs, apply, take that inputs, break them into an array that is stored in a new RDD. Okay, here this is array, right? One array, two array, three array, four array. Okay, you have arrays now. You have arrays now. That arrays are stored in a new RDD. That is all your map function is doing. Now let's go to flatMap. I am done, guys. I'm done. This is the last slide. If you understand this, I can end that. A flatMap function is similar to a map. Okay, with exception that it performs an extra step to break down or flattens the component part of elements such as array or a sequence into individual elements after running a map function. Very simple, very simple. Now guys, first I'll show and then I'll explain. Okay, this is your map function, right? I'll just do something which is, sorry, flat map. Okay, I changed map to flat map. Okay, oh, it doesn't have flat map. We have not defined it actually. So what I need to do is I will do like this. Let me RDD line split is fine. Okay, which is perfect. And then you apply RDD flat map as an definition, and this definition is going to apply on RDD split line. I'll explain it very clearly, don't worry. Okay, spelling mistake, it should be flat and then M uppercase. Now it has taken. Now see the magic. RDD flatMap dot collect is not defined. Let's start beginning. Let's because I have broken while I'll do it from beginning. 1 minute. No, it's not a matter of small f. Okay, yes, it is a matter of small f because that is spelling. If you see here, my RDD is in the small f, but I have given a big F here. That's a problem. Okay, this is fine, don't worry about it, but one thing you have to understand here is where did it break the line. That's what I was trying to understand. Let me do it again. 1 minute. I'll start doing it again. No. Line split. Line dot split. Yeah, you're right. But line split is my input, right? So what I have to do is line split dot split function. I have not used it. That was my mistake. Split. I'll tell you what it's doing here. Don't worry. 1 minute. Give me a second. I'll explain you what I'm doing here. Okay. Now RDD flat map, again small f dot collect. See, guys, see what it has done is it is array of string. Amarnath is one array of strings. Amarnath is one string, was is one string, you is one string, and is one string, is one string, training is one string, Hadoop is one string, he is one string, wanted is one string, to is one string, make is one string, spark is one string. Like that, it has made array of string. Let me show you something. try to understand the difference between map and flat map. Okay, let me just go back one line back. Okay, I'll apply map function on top of this one. RDD line split dot map lambda function. Okay, I'll define it here. Lambda x dot split with space characters. Close this one. Okay, now RDD line split dot collect. Do you see here? This one has taken each line as one element, and that element is one string, and the output is array of string. Happy everyone? If you see here, your each element is broken into other elements considering space as a separator. The reason is you have asked your transformation to split your element taking space as a parameter. Your split functionality, your split method has taken your input and broken your line, and your line, every space is a delimiter, and one big element is broken into individual elements separating as a space. So now we have an array of string. Initially you had one big line as an element. That big line as element input is now broken into array of strings. Like that, you'll have keys, you'll have values, you'll have one key with a list of values, you'll have tuples combining everything. That is the difference between map and flat map. Now this is flat map result. Happy everyone? Now this is map result. Flat map nothing but flattens the data. Flattens the data means it further flattens your data based on the split functionality what you give. Do you want to split by comma? Do you want to split by space? I'll do something here. Let me make you clear that one also. Let's do things very clearly because this is Spark. This is our bread and butter. Now let me ls minus l cat spark demo.txt. Okay, now I'll copy this one. Okay, now API spark demo with comma .txt. Okay, append, paste. Now I'll remove this one. I'll give comma. I'll give comma here. I'll also give comma here. Okay, I'll also give, I don't have to explain this, but the reason I'm explaining you is I want to make your understanding clear, your basics to be strong. People who wanted to move into data science in future, you have to make sure your Spark basics are strong. Okay, now I have comma. Okay, now Hadoop fs minus put spark demo with comma .txt to user Hadoop thought works. Okay, enter. Now Hadoop, let me verify that. Hadoop fs minus cat I'll copy this whole syntax, let me not waste time, paste it here, and then you have this one, spark demo with comma.txt. Okay, paste. Okay, which is fine. Now PySpark. RDD test case 3 equal to sc.text file. In that I'll copy and paste this one. Okay, okay, which is perfectly all right. No spelling mistakes, nothing. Now let's do something. RDD test case 3, or I'll give RDD test case 3 map equal to, I'm applying on top of RDD test case 3 dot map function, okay, dot lambda function, and I'm giving Amarnath as my variable, and then I'm splitting Amarnath dot split. I have to mention comma because it is comma separated. Okay, now RDD test case 3 map dot collect. Did you see that? It has separated with comma. Now let me apply flatMap. RDD test case 3 flatMap function is equal to RDD test case, don't do spelling mistakes dude, case 3 dot flatMap, and in flatMap you have you have Amarnath, okay, and you can say Amarnath dot split with comma separated. Okay, syntax error. 1 minute. Yeah, lambda function is not there. Flatmap lambda function. Okay, now RDD test case 3 flatmap dot collect. Done. Okay, now there's no big difference from this output to this output. Okay, ideally what we were expecting, flatmap to go and count each value and go and consider each thing as an individual. Okay, but here you are given only one line. That is the reason why it has taken one input. Now what I'll do is, hold on guys, focus. One last scenario I want to explain. One last scenario, bear with me. The reason it has taken one input is it has only one it has only one input line. Okay, Vi Amarnath, sorry, not Amarnath, Vi Spark with comma. Append. Okay, I'll copy this whole thing, I'll paste it here. Here I'll change the name. Again Okay. You can put any number of lines. My only intention is to make you clear that each line is one input now, one RDD with elements. Okay. Now let me close this one. Let me open PySpark. Sorry, spelling mistake. I always do this. Now let me go back. Now RDD test case 4 equal to sc dot text. Oh, I haven't copied it. I haven't copied that into HDFS. Sorry for that. Exit. Bracket close. I have to copy that change file in HDFS, right? For that to read ls. So Hadoop fs minus put user HDFS. Sorry, user Hadoop ThoughtWorks. In that you have this thing. Paste it here. Thank you. Thank you. Thank you. Hadoop ThoughtWorks colon. What's the file name? Spark. One last scenario. We'll wrap up. Spark demo with comma.txt into Hadoop fs minus put to. I don't need this actually. I don't know why I have given this one. The file is already there. At last, do you want to replace it? Okay. Now let's verify. Hadoop fs minus cat user Hadoop ThoughtWorks. In that you have Spark demo with paste. Do you see that? You have 4 lines now. Fair enough. Now let's apply PySpark. Don't think why this guy is using a Python. There's no big difference. I'll show you that very clearly. Now RDD test case 4 equal to sc.text file, which is nothing but user Hadoop ThoughtWorks. In that, what do you have? I have what's the file name, man? Come on. Shit. Okay, that's fine. sc.text file. Copy. Paste. Okay. Hope you're enjoying it. Now RDD test case 4 map equal to RDD test case 4 dot map function. Okay, in that you have lambda function. In that you have x, and then you have x dot split. You're splitting with comma separated. Okay, now RDD test case you're doing map dot collect. Test case 4 map, because it's the fourth one, 4 map. Okay, 4 map dot collect. Okay, now see, Amarnath team is on Spark. Okay, now if I use flatMap on top of it, spelling mistake, it should be uppercase M. RDD test case 4 flatMap dot collect. Okay, now guys, you have Amarnath, you have team. The only difference why both are doing same work is this one. Okay, I'll show you that in the slides and then move here. Let me show that. One minute, where is that? Yeah, this one, flat map. If you see here, map is one transformation, one element comes in, one element comes out. Using map, 4 line elements were converted into 4 array elements. Okay, but we still started and ended with the same number of elements. The flat map function on the other hand is one to possibly many transformations. One element will come in, but many transformations will go out. Okay, in other way, the output is written as single list of individual elements rather than 4 list of elements that were originally separated by line break. This time, results on each words being treated as its own element, resulting 22 elements. 22 elements is nothing but 1, 2, 3, 4, 5, 6, 7, 8, like that. For them, the example is different, which is this one. If you see this one, Amarnath was training Hadoop 1, 1, 1, 2, 3, 4, 5, 6, like that. Okay. Now, the only difference is it is easiest to think about flat map as simply as map operation followed by a flatten operation in a single step. You can use map, you can use flat map. Both does the same work, but the only point is flat map will have one input to many outputs, whereas map will have one input as one output. For example, your first thing, I'll show you that. I'll show that. 1 minute. Let me I want to explain everything practically. If you are okay, I'm fine with it. So RDD map equal to sc dot text file. Any confusions, anything, any single thing also let me know. User Hadoop thoughtworks amarnath dot txt. Okay. Now RDD map dot collect. Let me first verify the data. I have the data here. Okay. Now RDD map RDD map dot map. Okay. In that I have lambda x. In that I have x dot split. Okay. In that I have space separator. Okay, close this one. Now RDD map dot collect. Okay, now it has given 4 inputs here. 1, 2, 3 and 4. Okay, now I'll do the same thing again. Carefully observe. I'm just changing map to F should be small case always and M should be uppercase. Okay, now if I do that, what happens is RDD map dot collect. It does the same thing. Okay, it is no big difference, but whenever you wanted to split each individual line and then do it, you have to mention very carefully, understanding the facts that flat map is nothing but it is simply a map operation applying a flatten operation on top of it. Okay, here if you understand the difference, map map, flat map. Applied on a transformation, applied on RDD, applied on RDD. Okay, the syntax is same: lambda line line dot split, lambda line line dot split, anonymous function lambda, variable line, and you are applying on each element of your thing as a line and you're splitting it by comma. That is the difference between map and flat map. That's all I have for today. I'll give you 5 minutes time to ask any questions. We can wrap up. Hope you enjoyed the session. Hope you are getting things very clearly. Any confusions, any wrong understandings, if my understanding confused you, feel free to ask. Happy to help. I ensure today's recording will not corrupt. Yeah, go ahead guys. Any questions? Come on, fast. It's getting late. 7:15 already. Quick, quick, quick.
Varun here.
Go ahead, Varun.
So, yeah, so flat map is more productive than normal map.
You can say that. You can say that. There's no big difference. Both does the same work. But flat map, if you still have big data, and if you have to make your next transformation easier, you apply flat map.
Okay. Right.
Next, anybody else? Any questions? Everybody happy? I'm really shocked to see there's no questions by anybody. Been telling Spark. Is it that my explanation is good, or is it that you didn't understand anything out of it? Guys, come on, getting late. Quick. Suresh. Everyone. 11 attendees. Ashok, Benazir, Madhu, Fani, Radhika, Rama, Sai, Sailaja, Suresh, Varun. Everyone clear? Awesome.
Clear, sir.
Very good. I appreciate that. Thank you all. I appreciate your efforts. Sorry for dragging it little late because I wanted to make sure yesterday's recording, people who didn't attend yesterday, you should be happy because it happened for a good reason that, you know, we have revised everything. Thank you all for your time. Have a great day. Enjoy your work. Tomorrow 5 to 8, Sunday 5 to 8. You have to bear with me. You don't have any other option. Okay. See you all. Have a great weekend. Thank you. Cheers. Bye.